Warning: tube amplifiers have lethal voltages inside them. Please do not attempt to build, test, or repair these without understanding and following all safety protocols. Hey y'all! Well, time to get back working on this push-pull amp, and I know it's been a little while since we've been working on this, but let's dive back in. One of the things I'm kind of kicking myself for is I didn't breadboard any of this, and this is really the first amp that I've had a problem with by not breadboarding it. And what happened was I was originally going to build a clone of a ST35, and so I pulled the transformer data off of the instructions for the ST35. And if I'd really done my research, I would have realized that Dyna really built those with the voltage too hot for those tubes. Now at the time, the EL84 tubes that were being used were really rugged tubes, and they had no problem running at voltages way beyond what their design specs were. But unfortunately, the EL84 tubes made today aren't that rugged. And I really don't want to build an amp that I put on this channel that struggles to be reliable with modern tubes. And so I bought a set of Gold Lion EL84s, and they're fairly expensive tubes. Didn't want to roast them. While they did survive the testing with the hot transformer that I had on it, I decided that I really wanted to go in a little different direction. And so I went from the other transformer that was, I believe, we had 330 volts on the plate, which is 30 volts or 10% over spec, which also drove the current too high with the cathode resistor that I wanted to use. And so I had to change that cathode resistor to try to get the current dissipation total for the tube down within what I felt was a comfortable range, especially for a push-pull amp. And then I'm like, well, I'm running lower current than I would like to run because of the voltage, and I feel like there's a balance point between the current and voltage where tubes really sound good. And so I put the brakes on the project and ordered a pair of these. These are 272BX Hammond transformers that are 600 volts center tapped. And they have a 5 volt and a 6.3 too. And the 6.3 is at 3 amps instead of 4 amps. So I'm hoping that the 6.3 voltage will be down more in a range that I feel comfortable with without having to load a bunch of heat building resistors inside the amp, which I don't like doing. But it does have the 5 volt for our tube rectifier, and it's actually a lot smaller footprint transformer too. Now it's not going to match now these blue, bell covers that these Edcores have. So I may end up taking these off, and in a future video we may do a little stuff on trying to do a DIY powder coating, which that could be another fun thing, or we may just end up painting them. Haven't decided yet. But the other problem is when I put these on the chassis, I don't know if you can really see, when I align these two holes, the other two holes are way back here. And I could put this back here. I haven't 100% decided yet which I want to do. And then have a couple of Allen bolts here. But I think that's going to probably look worse. If I move it up here in the front position, then I can put a couple little plugs in these two holes. They'll be behind the transformers. They won't be as visible. I could even play around with trying to fill them up with some epoxy. I haven't 100% decided yet what I'm going to do there. But I need to drill a couple of holes here. And then the center of this is going to be offset from this hole. So what I think I'm going to do is come in here and open up this hole so these wires can come over more. And then they'll be lined up with these grommets. And again, you won't see that, so I can, get a dremel tool, open the bell cover up a little bit so these wires exit closer to this bolt hole, and then they'll go through this grommet just fine, and then we'll have this thing where we want it to be. Also got to get some black hardware. I can't stand these silver screws. That's just a pet peeve of mine too. So anyway, I'm going to, get on with doing the fab work on this, and then hook up this transformer, put the other cathode resistors back in it that we were originally going to use. And in the past, I've mounted my cathode resistors on top of the amplifier to help dissipate the heat. And going to try something a little different on this one. I know some people don't like that they're exposed like that potentially there's some voltage there, and I get that. So I'm going to try mounting them with this thermal tape that I got, cut little pieces of it, and it should really help transfer the heat to the chassis and, not have heat buildup underneath the amp as bad by transferring the heat to the top side through this thermal tape. So now I'm going to get ready and start doing this fab work. Okay, so here's our transformer that we're going to be using, and you can see it's way smaller than this EdCore one that we were previously planning on using. This was 660 volts, and this is 600 volts, both center tapped. And so this is about 10% lower voltage, which is really what we want to see. Also, these Hammonds have dual taps on the primaries. They have a 125 and a 115 volt. And so given that we've got 120 volt, running this 125 volt primary tap should bring the voltage down both on the plates of the tubes and on the heaters for the other tubes. So I really think this is going to work out excellent. So the issue, like I said earlier, you can see when I have these holes lined up that now we have this hole back here. And I think I could just put a couple of just Allen screws in there, even though they're not going to be doing anything, to kind of fill in these holes. Little button head screws, or like I said, maybe I could find a couple of black plastic plugs at the hardware store, and then drill some new holes here for the back hole. The other problem we're going to run into, though, is see the wires come out in the center, which would be right here. So I'm going to come in here with a file or a Dremel tool and window this out a little bigger so that these wires can exit over this grommet. And then, yeah, I mean, ideally we just throw this chassis away and re-drill everything, but I'm not going to do that. And then on the mirror image, it just won't have these two little plugs, and we'll put the transformer in the same place. So I don't think that's going to be a big deal. And again, this is the first time I've really kind of got caught out totally ordering the wrong iron and being kind of stuck with having to do something like this. The other thing that we're going to have to do, and I'll show you on the underside here, I'm going to mount it like this, where we have the power leads on this side, so they'll come just right up here over to where the switch is, or this is going to be the switch wire, and this is the power connector. Then the heaters will come out here, they'll come over here to the 5 volt, then they'll come up here to these two terminals right here, or for the heaters. So I think this is really going to work out well. Okay, so we're ready to drill a couple of holes here that we've marked, and we'll get our little automatic center punch here, give a little one there, and one there, and then we'll drill a pilot hole. And then we come back and drill the full-size hole. Then we'll double check that the screw hole's the right size. That looks good. And then we'll come back with a larger bit and chamfer the edge of these holes. And flip it over. Do the inside. There, we should be able to bolt down our new transformer. Okay, so I got the power transformer installed, the new one, and again, this is a 600 volt center tapped Hammond transformer, a 272BX, and it's rated at 115 milliamps, which is plenty for this monoblock because these tubes are going to pull approximately 80 milliamps between them, and then we'll probably get another 10 out of this, so we're still well within the headroom with this. I ran the high voltage, comes over here. This is the 600 volt center tap, goes to these two pins on the tube, number 4, number 6. Center tap goes to our star ground point. The power leads, there's a white and a black, which is 125 volt, which is what we're going to be using. The 115 volt we have just tucked up under here. We're not using it. It's heat shrinked off on the end. It's connected to here on the inlet connector. The fused inlet connector goes to the switch, which is a twisted pair of wires that run around here to the front, back, then to the power transformer. And then these green wires are the 6.3 volt. And these are our 5 volt that go to pins 2 and 8. Pin 8's where we pull the DC off. We're actually using pin 7, which isn't connected to anything on the tube, as kind of a tie point for this first filtering cap. And then the power goes to the choke, which is a 8 Henry, 100 milliamp choke. Power comes out of it, goes over here to our big storage cap, and then the DC comes over here, goes to the transformer, and then comes out to the tubes. And then we have another point here that we're going to use for getting the B plus over to our driver tube with some resistors and stuff over here, but that's for the next video. This little guy right here is a little bridge rectifier with a filtering cap that we're going to use to get low voltage DC to run up to our light on our power switch. And we'll have a resistor in series to get the brightness where we want it. Over here we have a voltage divider. The B plus comes up and over. Got these two resistors with this one cap. That's the ground. The center point here is going to be approximately 50 volts, which is what we're going to raise the DC offset on the heaters to. Now, this transformer doesn't have a center tap for the heaters, and so we're going to have to use a couple of 100 ohm resistors from here to there, and from here to here to create a virtual center tap for the heaters, for the drivers. Mainly we're raising it for this input tube. Now that we got all this wired up, it's time to power this thing up and see what kind of voltage we're getting. If you remember last time with the 660 volt transformer, we were going way beyond spec of the tubes, and we're having to try to running a really weird rectifier tube to try to get, putting resistors and stuff in here, trying to get the voltage down. And then the 6.3 voltage was, I think, almost 7 volts. And so that's when I just kind of punted and decided to get a different transformer. Now we still may be running these tubes a little hotter than spec, but I think we're going to be in a range that I feel safe using. So let's do some voltage tests here and see what we've got. In series with the amplifier, we have a variac, we have a isolation transformer, and we've checked the voltages on the input, and we got right at 121 volts on the input, which is what my line voltage normally is. And so I went ahead and bumped it up to about 122 just to make sure that we're getting what normally I would see on my line voltage. And we're going to hook up This will lead to the plate, and this will lead to the ground. And then we're going to put this thing on DC volts. And let's see what this thing does. And you can see with this tube rectification, it takes a little bit for the voltage to come up. And it's over 400 when it's not conducting. But as soon as the tube starts conducting, let's see where this thing settles down to. Just under 340 volts. So the next point I want to check is going to be on the cathode and see what kind of dissipation we have on these tubes. Okay, so we switched the probe over to the cathode and we have just over 12 volts with a 330 ohm resistor. And running it through my calculations, that's about 85% dissipation, using the spec that this is a 14 watt tube, which is what Gold Lion calls theirs, and so we should be safe. You subtract the 12 volts from the 240, and so we then have 228 across the tube, which is higher than the spec, but most of the stuff I've read online that a lot of people run these at around 330 volts and don't have any problems. And again, that's not on the plate, that's from the plate to the cathode across the tube. So I think we're going to run with this and just see how this thing works out. The next thing we want to measure is the screen voltage, so let me move the probe there. Okay, we got the test lead on the screen, and we have 336 volts. So we have about 3 volts lower on the screen than we do on the plate, which is about what I like seeing on a pentode tube between the plate and the screen to make sure that the screen is a few volts lower than the plate. So happy with that. Next thing I want to check is see where our heater voltage is, because that was something we had a problem with the previous transformer. So let me switch the leads over there and power this back up. So we got this hooked up to the heater, switch this to AC volts, and you can see we got 6.39 volts, which is well within spec. And we still have the other tube to put in the front socket, and which will probably pull it down a little more, along with the 100 ohm resistors that we're going to have to put for the voltage divider. And so I think we're going to be in a perfect spot for this. So I feel like we resolved all the problems that we were having with the other transformer going to this lower voltage unit, and we're able to use this 5U4C Soviet tube, which I originally had wanted to use with this, and which I have a pair of, and so I think we're good to go. The other thing that I wanted to talk about for just a second is, let me go ahead and turn this off since we've checked all our voltages and everything seems to be okay. The other thing that I'm thinking about trying on the other monoblock that I build is building it with a 550 volt center tapped transformer. Doing some calculations, it looks like that would get the plate voltage down to right at 300 volts. And then instead of running these 330 ohm cathode resistors, I can run 270 ohm cathode resistors and run the plate voltage lower but the current across the tube higher, which ends up at the same dissipation level. And I'm really curious what that will do to the sound of the amp and the distortion and how it performs. And so building these two monoblocks a little differently than each other with the ability to use this higher voltage transformer if I decide to go that route, I think it'll be a fun thing to do for this channel and this project so that we can kind of experiment and how changing the relationship between those two values affects the sound and the power and the distortion levels of the amplifier. So I think that'll be a fun thing to do, like I said, with building these monoblocks, and being that they're single channel amps, I can switch from one to the other and, listen to them and, listen to one channel and then the other and see which one sounds better. And then whichever way to me sounds the best will be the way that we recommend building this. So anyway, I think we're going to wrap this video up right here and then get to work on doing this input tube and get this thing finished up. Well, as you can see, that new Hammond transformer really made a difference, and it got the voltages back to a range that I'm comfortable with. I just didn't feel like it was safe going that high over the max voltage spec if we're going to be using modern tubes in this design. So anyway, as you can see, we ended up where we wanted to be. We got the heater voltages down within the range that I feel comfortable with, and now we can go to work on wiring up the input tube, getting the cathode bias and everything set on it, and get ready to start doing some testing on this thing. As you can see, this was a fairly simple amplifier to build. Once we get done and we're going to run through the whole test on this, obviously this is only one channel. I'll have to build the mirror duplicate for the other side, which I'm probably going to do off channel because it's just going to be a mirror duplicate of the same thing we just did, although it won't have the extra holes in the back of it like this one ended up with. So anyway, hope you're enjoying this build. Hope you're enjoying the channel. If you are, please subscribe. That's super important. We're almost at 5K subs, and that's going to be awesome once we get to that point. Like the video. That helps the algorithms to get this thing propagated. If you feel so inclined, there's a link to my donation page below. Send me a few bucks, make Skunky smile, and we'll see you soon. Have a great day.